the result is a third vector. In other words, another vector different from A and different from B. So because the result is another vector, this type of vector multiplication is also called a vector product. Not because you're multiplying two vectors, but because the result of that operation is a vector. So because the result of this product of two vectors is another vector, we have to specify two things about that other vector. We have to specify its magnitude, and we have to specify its direction. In the case of the dot product, it's easier because the result is a scalar quantity, right? So all we need is a number. So one calculation and that's it. But with the cross product of two vectors, the result is going to be a third vector, and as such, as another vector, it's got magnitude and direction. There are two things we need to figure out: the magnitude and the direction of that result of that cross product. So let's calculate the magnitude first. So the magnitude of, let's say, A cross B, and the reason why this is called a cross product also is because you use a cross to represent that vector multiplication. So the magnitude of A cross B is, so the magnitude of A cross B, that's the magnitude of A cross B, is the magnitude of A multiplied by the magnitude of B, but this time multiplied by the sine of the smallest angle between A and B, between vectors A and B. So this might be vector A, this might be vector B. So again, the smallest angle between them. So that's how you find the magnitude of this cross product, of this third vector. This is a definition here, and this is like a definition here. Now, what about the direction of this cross product? So I'm going to call this B. The direction of A cross B is, sometimes people just define A cross B as C. You know, suppose I can instead of writing A cross B, I can just write C to represent A cross B. But all right, the direction of A cross B is perpendicular to both vectors A and B. So it's perpendicular to both of them. So for example, if I want to know the cross product of a vector represented by the blue marker and a vector represented by the red marker, let's say the vector represented by the blue marker points up and the vector represented by the red marker is to your right, then the cross product of these two vectors is going to be a third vector, and it has to point perpendicularly to both of them. And that only gives you two possibilities: perpendicularly so that it's towards you, or perpendicular to both of them so that it's towards me. Okay. The magnitude is going to be the magnitude of this times the magnitude of that times the sine of the angle between them. But the direction has to be perpendicular to both of them. So it's either that way or this way. If I have the two vectors that I calculate the cross product of like this, let's say red cross blue or blue cross red, the only two possible directions for the cross product of these two vectors is either up or down. And if the two vectors are like this, then the only two possibilities are to your left or to your right. Yes? So it has to be perpendicular to both of them. To not just one of them, but both vectors. Now, which is it? So if I want, for example, red cross blue, and the order in which I write down the vectors is important. If I say red cross blue, it's not the same thing as blue cross red. So if I say red cross blue, then the two possibilities are either to your left or to your right. Well, it's one of them. Which is it? So I use a trick. If I define the cross product like this, then, this is the third vector, right? So what I do is I use these four fingers of my right hand, and I keep them straight, and I point my four fingers of my right hand in the direction of the first vector, whatever appears over here. So this will be my four straight fingers of my right hand. This is just a trick. And then the palm of my right hand will face in the direction of the second vector. So palm of right hand. And then the answer is going to be in the direction of my thumb, the thumb of my right hand. So, four fingers, first vector, palm, second vector, thumb. Answer, the cross product. And there are many cross product equations that we are going to write down. In fact, today I'm going to write down this. So, these are some quantities here, but then I have the L cross R hat is going to be the direction of the B. So, four fingers, palm, thumb. And this has to be perpendicular to both of us. We are going to write this equation also, eventually. And here you'll have to be careful, because when I multiply these two vectors, I'm going to get a third vector, right? And how do I find the direction of that third vector? Four fingers, palm, and then my thumb will point in the direction of this, right? Now, well, what happens if this charge is an electron that's negatively charged? Then the direction of this vector is going to be in the negative direction of my thumb. So one has to be careful. Yes? We're going to write a formula like this. In this case, the length of something is always a positive quantity. So, four fingers, palm, thumb. We're going to write something like this. Four fingers, palm, thumb. Right? Some people memorize, oh, your thumb has to be like, they think of this formula, right? And in this formula, B, well, stands for magnetic field. And so, four fingers, palm, thumb. And then they memorize, oh, the magnetic field is the thumb. But wait a minute. In this formula, the magnetic field is not the thumb. B, the magnetic field is not the thumb. It's the palm. Four fingers, palm, thumb. Four fingers, palm, thumb. So don't memorize, oh, the magnetic field has to be this finger or this palm or the thumb, or don't memorize it like that. This applies to any cross product in the universe. I don't care where you take it and what it pertains to, what the subject is, if it's fluid mechanics, if it's electromagnetism, if it's vector, if it's calculus, I don't care what it is. This is universal. Okay? Right? This will be perpendicular to this too. And one trick, this is just a trick. By the way, this is not the only trick. I could use a left-hand rule. Right? I could say first vector, second vector, and thumb. I can play with, if you're left-handed and you want to come up with a left-hand rule, it's okay. But once you figure out the directions, it's always going to be the same, right? You should always get the same direction if you do it using the correct convention. So, not difficult to calculate the magnitude of the cross product. The direction is where we have to be careful. It has to be perpendicular to both of them. But once I know the two vectors that I'm taking the cross product of, there are two possibilities. So it's the one determined by what's called the right-hand rule, because I was using my right hand. So I'm not done over here. As determined, it's just a rule, a trick, something to, do this more quickly. So what would be the direction of blue cross red?
Towards the walls.
To your right or to your left? Blue cross red. So I said blue first. It matters what the order is. Blue, 4 fingers. Red, palm. So 4 fingers, blue, palm. My thumb points that way. So it's to your left. Yes? What if I say red cross blue?
Down.
Well, before you start doing this, what are the two possibilities?
Up and down.
So don't say, oh, it's gonna be up and down, and then you do this, and it's that way, right? So don't change it. It's either gonna be up or down. So 4 fingers, palm, thumb, down. Yes? Blue cross red. Which way? Blue cross red. Towards you. Blue cross red towards you. And it isn't literally in the direction of your thumb. I mean, you have to know that there are two possibilities, and you have to know what those two possibilities are. The thumb is just telling you it's more in this direction than the other one, right? Because if I do this, if I say red cross blue and I do this, my thumb actually points towards me right there. And I don't know if you can tell, but I broke my thumb when I was 14 years old playing soccer. It's crooked. I don't know if you can, it looks weird. It's like this way. I remember. Last day of school in the Bronx, middle school, I think was it? Last day of, bless you, of middle school, yeah. And in June 21st or something, and then, I just went out to play soccer, summertime, and excited. And first day of the summer, and then boom, I broke my thumb. And then this happened like around 4 o'clock in the afternoon. So I went to a hospital, Lincoln Hospital in the South Bronx, and they were taking forever. Like, I was there for like until 9, 10, and they still had not called me in. So I went to another hospital that I knew was a better hospital in Manhattan, Presbyterian Medical Center. And then they took care of me. And I remember the doctor, they put a cast on me like at 1 o'clock in the morning. And the doctor wanted to straighten it. And I said, don't you try. Don't you even try. I don't care if it's crooked. I was in pain. It had been many hours since it had broken. So, yeah, then my parents picked me up, and then I went home. And I remember the doctor said, that was on a Wednesday, and the doctor said, well, you come back in 3 weeks. That's when we're going to remove it. And then they gave me a slip for my appointment to remove it. And I said, well, 3 weeks. So I went 3 Wednesdays, in 3 weeks. I went back 3 Wednesdays, right? And it turned out that my appointment was for the day before that Wednesday, for that Tuesday. So, I could have had this thing taken off. Summertime and you got a cast up to here. I said, what, why, gotta do that, right? I remember I used to hang out in the Bronx and, it would itch, with humidity, and I had a knife in there like that. And I carried it around. Right? It was for scratching, not for stopping people, right? It was for scratching because it would itch, So my goodness, I said, I could have had this thing removed yesterday. No, you gotta come back tomorrow. We only remove casts on Tuesdays and Thursdays. Oh, okay, so tomorrow. Guess what? That night, there was a blackout in New York City. People were looting all over the place, at night. And I remember watching from my apartment, there was an A&P supermarket. People were just walking out with stuff, and my goodness. So I go the next day to the hospital. Oh, we're not removing them today because, it's a blackout. We're using the generators for surgery and so on. Come back next Tuesday. So I had to wear that thing an extra week. And so I went on that Tuesday and I was upset, but anyway, I went that next Tuesday. And as soon as I got out from the hospital, I took the bus from 168th Street in Broadway all the way to Vancouver Park, from the first stop to the last one, all the way to Vancouver Park in the northern part of the Bronx, because there was a public swimming pool. I was straight to the swimming pool, right? And then we were hanging out with some friends and some, a lot of friends. And, the pool, the water is up to here, right? So I get on top of one of my friend's shoulders, stand on it, and I jump, and I go down and crack, hit the bottom of the pool. So I went like this, right? I sat, outside of the pool, and I was almost crying. And I said, I'm not going to go to the hospital. They're going to put another cast in me. So anyway.
Did you pop it back into place after that?
What's that?
Did you push it back into place after
No.
that?
I was in pain. It was in a lot of pain. And I just couldn't play anymore, And I wasn't even going to accept putting another cast on it. Forget it, So anyway, So the direction of the cross product is not literally in the direction of your thumb, is what I'm saying, right? So if I say blue cross red, right, the two possibilities are to your left or to your right. So if I go like this, right, so again, my thumb is going to point at some angle like this. I don't have to oh my goodness, it's going to point that way, right? So, but it points more to your left than it does to your right. Yeah? So it's just a trick. Okay, so what about this unit vector cross products? What is I cross I? What is I cross J? What is I cross K? And then J cross I, J cross J, J cross K. And K cross I, K cross J, and K cross K. Do you know any of these values? How much is I cross I?
0. Sign
Zero.
of 0
Why?
is 0.
How do you know it's 0?
Sign of 0 is 0.
Yeah, because let's say you say, oh, I cross I is going to be some vector. Let me calculate the magnitude of that vector. So it would be the magnitude of I hat, which is 1, times the magnitude of I hat, which is 1, times the sign of the angle between I hat and I hat, which is 0. And the sign of 0 is going to make it 0. So I cross I is 0. Just as J cross J is 0, and K cross K is 0. Notice that is the opposite of this, right? In the dot products, when they're the same vector, you get a 1, right? When they're the same unit vector, you get a 1. Same unit vector, you get a 1. But with the cross products, when they're the same unit vectors, you get a 0. Same unit vector, you get a 0. Same unit vector, you get a 0. Now, I cross J, that's going to be a vector. You're taking the cross product of two vectors, so the answer has to be a vector. So what is the direction? What is I cross J? Anyone know?
1.
So let's calculate the direction. Let's think of it like this. Can I erase this?
Yes.
let's think of let's say this is the x-axis, this is the y-axis, and the z-axis is out of the board. So I hat, it's a vector of magnitude 1 that points in the positive x direction. J hat is a vector of magnitude 1 that points in the positive y direction. And k hat is a vector of magnitude 1 that points in the positive z direction. So they're all mutually perpendicular to one another. So if I calculate, when I do I cross j, the answer is going to be a vector because it's a cross product. So what is the magnitude of that? So the magnitude of I cross j will be the magnitude of the first vector times the magnitude of the second vector times the sine of the angle between I hat and j hat. But the angle between I hat and j hat is 90 degrees, right? So the magnitude of I hat is 1, the magnitude of j hat is 1, and sine of 90 is 1, so it's going to be 1. So the magnitude of the cross product of I cross j is going to be 1. The question is, what is its direction? So, 4 fingers to your right, palm up. Which way does your thumb point?
Okay.
4 fingers, not left. I mean, left hand.
Along
Use
the-
your left hand, use your right hand.
Along the z-axis.
So it points out of the board, right? Which is, so I cross j is a vector whose magnitude is 1 and points out of the board. Right? I, j, my thumb points, obviously it doesn't point, it points like that at an angle, but you know what I mean, right? So it's out of the board. So what is the vector whose magnitude is 1, which points out of the board?
Okay.
K hat. So I cross j is k hat. K hat. Get it? You look unhappy.
I can mess up between the order of the two cross vectors. So
4 fingers is the first one, palm is the second one.
Yeah.
So 4 fingers. In that picture, it's to the right of your right hand. Second vector is your palm. That's pointing up. So 4 fingers to your right in the direction of I hat, palm, j hat. My thumb comes out of the board. So it's going to be in the positive z direction, but the magnitude is 1. So that's defined as k hat. What is the cross product of I cross k? So if you calculate the magnitude of I cross k, you get the magnitude of I hat, the magnitude of k hat, times the sine of, what's the angle between I hat and k hat? 90. So this will be 1 times 1 times 1, so this will be 1. But what is the direction of I cross k? So 4 fingers to the right of your right hand. Your palm has to be out of the board. So while my 4 fingers point to the right, my palm has to be out of the board. This is actually easier for me. And my thumb points downward. Well, down is in the negative y direction. So what is the vector whose magnitude is 1 and points in the negative y direction?
Negative
Negative.
J.
Negative what?
J hat.
J hat. Correct. And if you do this, this would be minus k hat. This would be I hat. This would be j hat. And minus I hat. When you do all of those. If you don't like the 4 fingers, palm, thumb thing, do you know how to use a screwdriver?
Yes.
Because some people don't. Some people they put the screwdriver in the head of the screw and they don't know which way to turn to loosen or to tighten. Do you know?
Righty.
So if you know which way to turn it so that it tightens the screw or to loosen it, so here's something you can do. Take, see, C is going to be in the direction in which the screw advances. So take the first vector and swing it towards the second vector and keep swinging it. So, and then in which direction would the screw advance? So, for example, if I say, suppose I say blue cross red. So blue cross red. So I take blue and I swing it. Screw would go that way. Right? If I keep turning it, the screw would advance that way to your right. Blue cross red. See, blue, red. So if you can picture, okay, I'm going to take this and I'm going to rotate and I'm going to keep doing that. The screw would advance that way. If I do red cross blue, so red first, blue second, so I take red and I swing it towards blue and I go, it's gonna go up. Now, if that's something that, then forget about it. You can do the right hand rule. And for most of us who are right-handed, I'm right-handed, as most of you are, we need to be careful because especially in exams and quizzes, we use our right hand to write. Right? And we don't want to waste time because, oh my goodness, I only have 2 hours to do this, right? So then for the test. So, but you don't want to waste time. So the tendency is to you don't want to let go of the pencil or pen and you start going like this with your left hand. So if you do a cross product problem in a test and you're right-handed, I don't know, sit on your left hand while you do that problem. So you put it down and then you do the thing if that's what you need to do. If you're left-handed, then you have an advantage. Okay, so, left-handed people have some advantages relative to right-handed people. So, I mean, if I were you, I would, when you go to bed tonight, then you put your head on the pillow, right? Then after you say your prayers, of course, right? So, okay, I had this to the right, Jay had this to the left. So which way is I cross K? And then, okay? So, I mean, so you don't have to depend so much on the hand. I mean, you could do that in the beginning, and then after you do many cross products, and you'll be able to, like, I've done it so many times that I just look at the vectors and I know which way the cross product is going to be. Because I kind of use the screw thing, right? Then I know which way the screw would advance, and so on, right? And if that's confusing to you and it's like, no, I'm never going to learn this because it's too difficult, you could also use this trick. You could put them in like a circle, I, J, like a clock, okay? And the hand of the clock goes this way, right? So if you go in the direction of the clock, the answer is the other vector and it's positive. So I cross J is going to be K. J cross K is going to be I. K cross I is going to be J. I cross J is going to be K. J cross K is going to be I. K cross I is going to be J. But if you go backwards, it's the other vector, but with a minus sign. So I cross K is going to be minus J. K cross J is going to be minus I. J cross I is going to be minus K. I cross K is minus, you get it? Check those. Over here. For example, like this one. K cross I wrote J. Well, K cross I is J. How about this one? K cross J. K cross J is minus I. That's what I have over there. I cross K. I cross K is going backwards. It's going to be minus J. There you have it. So just a trick if you. All right.
You can also just use the determinant, right?
Yes, you could also do that. Yeah. And sometimes I use it, and most of the time I use it. Or just multiply it out. I mean, to touch on that, if I have suppose A is ax I hat plus ay j hat. Suppose this is a vector in 2 dimensions. Just keep it simple. Right? And vector B is B x component I hat plus y component j hat, right? And I want to know what is, so this is given. So question. What is A cross B? So how do we do this?
Should be AX times BY minus AY times BX.
Okay. Something is missing there. You gave me a scalar quantity. What about the direction?
Oh, you still have to add the 2 zeros at the end to make it up.
So let's do it one way. Suppose, let's say this is one way of doing it. So I write A cross B equals AX I hat plus AY j hat cross BX I hat plus BY j hat. And I just multiply it out. So this will be what? AX BX? Yes? The cross product applies to the unit vectors, and this would be I cross I. Plus, and then this term multiplied with the second term on the over here, right? So that would be AX BY. And then this would be I cross J. Plus, then I'm going to multiply this term with the first one, and then this term with the second one of the other one. So this would be AY BX J cross I plus AY BY. You can see why I wanted to just do this in 2 dimensions, right? Imagine if I did it, but then I would have 2 more terms if I had the z-axis in there. Are we good with this? Right? I just multiplied this by this, and then this with that, and then this with that, and this with that, and you get 4 terms. Now, but what is this? From over there. What's this? What's this? And what's this? Well, this will be 0, right? And this will be 0, and I cross j is k, and j cross I is minus k hat. So therefore this becomes this is going to be 0, so it'll be AX BY k hat plus AY BX times minus k hat. Well, factor out k hat, and I get AX BY minus AY BX k hat. And this is what you mentioned, but the k hat was missing in the answer. So you don't even have to memorize this. You can just, if you remember this, you can do any cross product. If you express the vectors in terms of unit vectors, then you just multiply it out, and then you'll get there eventually. Or I wouldn't like to do it like that. There's a faster way that I use to figure that out. And this is using determinants. So here is just multiply it out here. So you write A cross B. So you write a determinant with the first row, I, J, K, the 3 unit vectors. And then in the first line, in the second row, you write the components of the first vector. So this would be AX, AY, and AZ, which in this problem, what is the Z component of vector A? Right, because this is like plus 0k hat plus 0k hat. So then I would write over here A0. And the third row are the components of the second vector in the cross product, which in this general case would be b sub x, b sub y, and 0. And then I evaluate this thing. Now, the way that I evaluate this, there are various ways of evaluating this determinant. The way that I do it is I copy the first two columns again, and then this would be AX and AY, and then BX and BY. And then my shortcut, if I do it like this, is that if I multiply like this, and like this, it's a positive answer. If I multiply in the other direction, like this, and this, it's a negative answer. So, if I'm gonna do the I hats first. So I say I hat multiplied by AY times 0, which is gonna give me 0. And then when I multiply this way, minus 0 multiplied by BY. I'm gonna write it down just for you to see, but I can tell right away that the answer is 0. And then I say plus, then I do the next one. So J hat, and then if I multiply this way, it's positive, if I go the other way, it's negative. So it will be 0 times BX minus AX times 0, which again is gonna be 0. And then I do the third one, K hat, which will be then, going this way is positive, AXBY minus, because when I go the other way, and then AYBX. And these are not 0, but, so therefore, this is 0, right? This is 0, so I get same answer. So this should be the same as this. So which method you use? Whatever you feel more comfortable with. If you're comfortable evaluating determinants, you can. That's how I do it. Because I can then see it, and I don't have to multiply all of this out. It's a matter of which method you like better. No, they didn't teach you this trick of evaluating determinants, 3 by 3 determinants.
I feel like.
I mean, the other way of doing it is you say, you say, okay, I hat, and then you eliminate this and that, and then you say AY times 0 minus 0 times BY, which is essentially this, right?
That's how.
But then when you go to the next one, you gotta multiply by a minus 1. Then you say, okay, then minus this, and then you eliminate this and that. And then it's AX times 0 minus 0 times that. That's still going to give you 0. But then plus K hat, and then you don't have this anymore, right? So then you eliminate this and that, and it'll be AXBY minus AYBX, which is this, right? So that's usually the way they teach you how to evaluate determinants. But my math professor taught me that trick, and I found it easier, and that's how I do it. Okay. He's the one who also taught me the, like the clock, if you go this way and then the other way, it's another trick, right? So, it's interesting. I took 4 math courses from him, and he was very, very good. So, as physics majors, and we, we had a semester system like we do at OCC. So we had to take calculus 1, 2, 3, and then advanced calculus 1, advanced calculus 2, and advanced calculus 3. So I took advanced calculus 1 in the summer, right before the beginning of my first semester in college, and then I took calculus 2 in my first semester in college, the fall. But then I took from this guy calculus 3, advanced calculus 1, advanced calculus 2, and advanced calculus 3. And he was just amazing. He was just very, very good. The other people were good too. I was lucky that he was Kamenetsky. I remember his name. Kamenetsky. Okay.
Six semesters of math sounds like a lot.
Is that?
6 semesters of math sounds like a lot.
Well, calculus 1, 2, and 3. Advanced calculus 1 was like differential equations. Advanced calculus 2 was linear algebra. And advanced calculus 3 was complex variables. Here they give them just different names. And then you finish all of those courses, and you take more advanced courses in physics, and you realize that you don't know enough math. So in graduate school, I had to take a whole year of mathematical physics. So another 2 semesters. Although I went to graduate school at UCI, so it was 3 quarters of, it's called mathematical physics. But it's math, used to solve physics problems, but it's math. Okay, so magnetism. Are you feeling good with cross products? If you've taken calculus, or if you're in calculus 3, you probably begin with cross products and vectors, and so you're comfortable with that. If not, then learn it this way, and when you take calculus 3, no, I think all of you are in calculus 3, right? You must be in calculus 3 or so.
Yeah.
You don't have to be.
It doesn't have to.
Most people are dual enrolled in it right now, though.
So some of you are in, no, when you take physics 185, you must be in
Calc 2.
calculus 2, right?
Yeah.
So by the time you take this course, which is after 185,
You could be.
you
enrolled
should
in-
be in calculus 3, but what, some of you are skipping it for a while?
I don't think I need it for the computer. Maybe I'll have to take it.
Oh,
later,
it's
but for
because of
transfer, they
the
don't require it.
computer.